We have AP Calculus, Basic Graphing of Functions. This is actually Unit 1, and we're given this equation. And the equation is that f of x is equal to, oh, this is wrong. F of x is equal to 2 minus x over x squared minus 4. And we're going to be asked to do a bunch of stuff. We're going to have to be, we should be able to find the zeros of the function, holes in the functions, vertical and horizontal asymptotes. So the first thing I'm going to do with this function is I'm going to try to simplify this, and this is kind of the key for calculus always, is look for patterns. So look for patterns, look for clues. So with AP Calc AB, there's just tons of patterns, and if you can start to recognize those patterns, they'll provide you with some insights. So here, I recognize this as the difference of squares. So this is what I'm going to do here. I'm just going to rewrite my f of x. F of x is equal to 2 minus x over, and this is difference of squares, so it's x plus 2, x minus 2, isn't it? And from there, this started to give me something to think about here, because I realized, you know what, this is, I can look at this, and this is x, I'm sorry, 2 minus x, and neither of these have negative x. But what if I did this? What if we factor out a negative 1? So factor out negative 1 from the numerator. And that would look like this, wouldn't it? If I factored out a negative 1, that would make this positive 2. Whoa, sorry, that would make this negative 2, right? Because remember, we had 2 minus x here. So negative times positive x is this negative x right here, isn't it? And then negative times a negative gives us our positive 2 back. Okay? Now, if you're asking, well, why would you do that? Well, look what it does. It gives us, right here, it gives us a removable discontinuity, doesn't it? That is to say, there's a hole in this function. So the first thing I'm going to do is I'm going to make a note and say there's a hole at x equals 2. Right, there's a hole at x equals 2. Now, some people are going to go ahead and plug this back in. They're going to take out the discontinuity, and they're going to get the point 2, comma, what is it? Negative 1/4. And if that all works for you, go for it. If not, that's okay, though. Now I'm going to go ahead and remove this discontinuity here. So we get f of x is equal to negative 1. Remember this negative sign here, because it's still there, right? It's negative 1 over x plus 2. So the first question is, what are the zeros? Zeros. Well, to find zeros, set the numerator, the numerator equal to 0. So if you think about that, the numerator here is negative 1. Negative 1 equals 0. Solve. Negative 1 never equals 0. So here, no zeros. And this is my supporting math here. Then holes. Well, we found the holes here, right? We removed them, and the hole existed at, look, go back up here to look for that hole here, right? What number makes this 0? And it's at 2. So there's a hole at x equals 2, right? X equals 2, or the point 2, negative 1/4. Okay? The next question is vertical asymptote. To find a vertical asymptote, what we want is the denominator to the denominator equals 0 when but that doesn't cause the numerator to equal 0 at the same time. Well, our equation, if you remember, is f of x is equal to negative 1 over x plus 2. Sorry, plus 2 there, isn't it? So we want to know, when does that equal 0? Well, this equals 0 when x is equal to negative 2. So this is, right, this is the equation. This is the equation of our vertical asymptote, right? So there's our vertical asymptote. And the last question is the horizontal asymptote, and that's in behavior, right? Horizontal asymptote. And if you look up here, we have negative 1 over x plus 2, don't we? Now remember that the way we do that, well, this is even easier. Look, in this case, what's going to happen? As this number approaches an infinitely large number, the bottom part's going to get really big. The top's going to stay the same. It's going to approach a value of 0, right? So we have a horizontal asymptote at y equals 0. All right, so I hope that was helpful. Love to hear your comments.